So here's some data from a student. We can see for each of their samples that they collected from the pond, they have different estimations for the number of fish in the tank. So what we're going to do is we're quickly going to construct a box plot. So the first thing we need to do to construct a box plot is to construct a number line. And for our number line, we're going to need like a place to start, a starting point, and an ending point. So can someone turn on the mic and tell us what a good starting point might be and a good ending point for our number line, and then we can come up with a scale. If someone could turn on their mic and share an idea, that'd be great.
185.
Okay, 185, so we could start down at 185. And what might we go up to?
575.
Okay, that works. Now, what should we count by?
I don't know.
You're not sure? We have to think about that, right? So 185.
Fives are tens?
Tens is going to take a long time to get up to 500, right? So what's the difference between 575 and 185? We'll look at that difference. Let's look at our range. Is 390. I can move this over. So 390, if we count by maybe what, 20s? That's going to give us, we'll need 20 tick marks. I think that'll work. So I'm going to start at 180, and I think we should count by 20. So this is 20, 40, 60, 80, 280. Do you guys think that's a pretty good scale for this box plot? Not too bad. Okay. So now we have to find our 5-number summary. So what do we need for the 5-number summary? Guys, there's 26 of you in this class. Okay, we need the median. It'd be easier if you turn on your mics, but that's okay. Median. Maximum.
Interquartile, upper quartile.
Yeah, we need the lower quartile and the upper quartile. So what's the first thing we need to do in order to find these things, these 5 important numbers? What's the first thing we need to do with our data? We're going to put the data in order. 185, 205, 275, 283, 315. Okay, who can give me some of the 5-number summary we already see? Let's open our mics, guys. Again, there's 26 of you. It'd be great if we shared just some ideas here. So can someone turn on their mic and share if we know one of these pieces of information already? Max is 575. Okay, Lee, I see that. What other information do we see?
Minimum is 185.
Yeah, minimum is 185. Okay, what should we do next? You guys can type your responses. It's okay. Find the median. How do we find the median? Find the max. So the maximum we already found is 575. So how do we find the median? In the middle, okay? So is there a middle of this data set? Why not? 275 or 283, yeah, right? So if we're looking for the median, I'm just going to color code the median here. We'll do the median in red. If we're looking for the median, it looks like it's right about here, according to what you guys are saying, between 275 and 283. So how do we find the median? Find the average of the two numbers. Good. So we'll find the average of 275 and 283. So 275 plus 283 divided by 2. Mr. Rogers is grabbing his calculator. 275 plus 283 divided by 2. 279. It's also the number in the middle. Wow, Caleb beat me to it. Okay, great. This is the median. What should we do next? The IQR, well, we can't find the interquartile range, Lee, if we don't know the quartiles, right? Because the interquartile range is the difference between the two quartiles. Find the lower quartile range by finding the middle of the mean and median. The mean and median, lower quartile. Can someone turn their mic on? It'd be a lot easier if you shared with your mic on. Lee, can you turn your mic on? Or Sandra, who was sharing? I mean, Sabrina, who was sharing. Carter was sharing. There's 26 of you out there. Oh, your brother's Google Meet. Okay. So how do we find the lower quartile? Can you guys type what you think the lower quartile is? Type it in your responses. What do you think the lower quartile is? What do you guys think? Do you think Lee is right with 205? So if we found the median, now for the lower quartile, we're just looking at the first half of the data, and we're looking for the number in the middle, right? So yeah, that's going to be 205. And now let's try to find the upper quartile. 315. Good. So now we can construct our box plot. We have our median, which is 279. So it's right about here. We have our lower quartile, which is 205. So 200, 220, so it's pretty close to 200. I'm just going to label this as 205, and you should do this on your own as well. It's easier to see. And this is what mathematicians would usually do if their scale is like spread out like ours, so we know exactly what those values were. The upper quartile is 315. Now I'm going to construct my box. Now we have our minimum, which is 185. And our maximum, which is 575. Okay, let's get the mic open. Let's just talk about this a little bit before class ends, please. So let's at least a few of us, please open your mic if you can. If you can, I know if you can't, you'll just type. But those of you that can open your mic, that'd be great. What are we noticing? What do we notice? And you can type if you'd like. Otherwise, let's open our microphones. It's more towards the left. Okay. What else are we noticing? Is there anything that's interesting or that we should be talking about or wondering about? There's variability. Li Dong, where do you see the variability? Where does the rest of the class see the variability? The greater 25% is more spread out. Carter, are you talking about this section right here? It's more spread out. Why do you think it's like that? Why do we think that section of the box plot is more spread out? Why do you think that that happened? That we have this huge spread in the top 25% of the box plot? Does anyone have an idea of why it might be like this? The range is 390. That's correct. The range is 390. Why do we think that fourth number, 575, is so far away from the other data? Does anyone have an idea why the 575 seems to be more spread out or like further away from the rest of our data that seems to be clustered more between like 180 and about 320? Does anyone have an idea of why that 575 might be so far away from the rest of our data? Why that we have so much spread here? Because it's bigger than 150 fish. What do you mean by the sample size? Let's get more specific. What sample size did the 575 come from? Was it a large sample, a small sample, a medium sample? Small, large. Ronnie, did the 575 come from a large sample? Let's check that again. Look right here. Did the 575 come from a large sample? Was that our smallest? That was our smallest sample size. So why do we think that our smallest sample size is giving us a result that's so far away from the rest of our data? Just so I want to try to. You guys can try to type some responses. Yeah, the sample size of about 30 fish. Why do we think that sample size is giving us data that's much further away? It's not like grouped with the rest because there's less variability. In a small sample, Carter, you think there's less variability in a small sample? Okay. What other ideas do we have? And these comments will be helpful when you do your write-up because the bigger the sample size, the closer the data will be. Oh, why do we think that the bigger the sample size, the closer the data will be? Or, yeah, the more clustered the data will be with larger sample sizes versus a smaller sample size. Carter, why do you think there's more variability in a small sample? What's your feeling about why this is happening? Why does that small sample? So Ethan, why is 575 so much bigger? Why did we get such a larger number in that small sample? Because the numbers are far apart. Okay, but when we collected the fish, right, you guys were collecting the fish in different sample sizes, and it looks like the smallest sample is creating data that's far away from the rest of our samples. Why do you think collecting a small sample of fish produced data that was far away from the rest of our data that we had collected? The bigger the number, the more spread? I'm not really sure what you mean by that. Which sample size do you think is the most reliable? Which sample sizes do you think are the most reliable for estimating the number of fish? The large sample sizes or the small sample sizes? Okay, back it up using the box plot. How do the large sample size compare to the information in the box plot? Here's our our largest sample size. The large sample sizes are more clustered together. So we're seeing more clustering with our large sample sizes. What about the relationship between our largest sample size and the median? Do we notice anything interesting about the relationship between our largest sample size and the estimated number of fish and our median for the estimated number of fish? I have to look back at the response. Can you type them again? Why do we... A majority of the samples in the 205 and 315 range. Good. So we're noticing that our larger samples fit more in our cluster of our box plot. So why do we think that really small sample size produced data that wasn't as reliable? Why do we think that small sample size produced data that wasn't as reliable? I'm waiting for some responses. Why do we think that small sample size of less than 30 fish in our sample produced data for the estimated number of fish that was less reliable or more spread out from the rest of the data? Again, if you could turn your mics on, that would be fantastic. If not, you can type in a response. And again, this is being recorded, so I'll be able to go back and see who was responding throughout the lesson as well. Lee, the question is, we're noticing that our bigger sample sizes are more clustered together. These sample sizes, the data for this are more clustered together. And I'm wondering why our smallest sample size produced an estimated number of fish of 575 that's so far away from the rest of our data. Why did that sample size produce the small sample size is only a very small portion of the data? Does anyone want to add on to that or share another idea? Like, why is the larger sample size kind of more accurate, but the small sample size is giving us a less accurate estimation? Mia's saying because it covers a small amount of the population. Mia, do you want to add on to that? Why do you think the larger sample sizes are getting us more accurate representations of the population? The large sample size includes more data. Good. Because there's more data. Okay, you guys are getting onto something here. Yeah. The larger the sample we create, the more data that we get. So it's going to give us a better representation of the population. The small sample size there that we have is showing us maybe we didn't catch enough data. We didn't get enough data from the fish. So it's kind of throwing our estimation off. Yes, Cheyenne, awesome. Because it doesn't have much data, so it won't represent the population well. It's a great way of putting it. Are there any last-minute questions before you guys move on to your own work? So this is kind of what you should be presenting to me on a piece of paper and taking a picture of, and then you'll be doing a small write-up on Google Classroom. Do you have any questions about that? The spread is much bigger than a majority of the clustered sample. Yeah, the spread is much bigger than a majority. That's a really good way to... That's the kind of stuff that we should see in the write-up. Can we start working? Yeah. So I'm going to end this session now, the help session. You guys can go start working on your work. If you have any questions, please reach out to me on Slack. This is just an example, Sabrina. That is correct. This is just an example.